Okay. Production function is given by this QKL. I'm going to write LK. L 2/3 K 1/3. L 2/3 K 1/3. Straight away you notice Cobb-Douglas production function alpha beta. Alpha plus beta is equal to 1. Therefore, constant returns to scale production function. If you have read your lecture notes, you will know. When alpha plus beta is equal to 1, its constant returns to scale production function. And you also know that because this coefficient is 1, it means 1 unit of labor and 1 unit of capital can produce 1 unit of output. Okay, this coefficient tells you the number of units of output that can be produced by using 1 unit of labor, 1 unit of capital. Okay, this is what you know about the production function. I am also told unit price of labor is W. Unit price of capital is R. W and R are the prices of the two inputs. Question asks you, derive the conditional input demands and the cost function. Standard, very standard question. Okay, conditional input demand. That means, what is the input conditional demand for labor and conditional demand for capital? That means, what is the cost minimizing bundle of labor and capital I need to use to produce what level of output? Does not say. So general level of output. If I had said to produce 10 units of output, then you should have been on the isoquant equal to 10. Here I don't tell you what level of output. So the general level of output 5. Graphically, what am I doing? I want to be on the isoquant corresponding to Q units of output. And my isocost line will have a slope of W over R. Therefore, the lowest possible isocost line I can be on subject to my isoquant Q. This is what I am looking for, L star and K star. This is what I am looking for. Okay, the question doesn't ask you to draw the diagram, and as I always tell you when you are practicing, always draw the diagram. It gives you a sense of what you are doing. How do you look at it? So this is the graphical solution. Analytically, how do I solve it? I am looking for the cost minimizing input bundle. In other words, I am choosing a value of L and K that will minimize the cost of the bundle, WL plus RK. L and K is the bundle. Subject to the fact that L and K, that bundle of two inputs, can be used to produce Q. That means Q is equal to L 2/3 K 1/3. This is what I am doing analytically. How do I solve this problem? I don't want, as I told you last lecture, when you are trying to solve this kind of a problem in producer theory, because you can't do any logarithmic transformation of the functions, if you try to substitute the constraint into the objective function, you will be in deep trouble. It will be very clear. Okay, so always focus on, this is the bundle I am trying to locate. What condition does this bundle satisfy? The first condition that this bundle satisfies is that at this bundle, the isoquant and the isocost have the same slope. Slope of the isocost, W over R. What is the slope of the isoquant? It is MRTS, which is, you will recall from last lecture, marginal product of the input on the x-axis, MPL, over marginal product of the input on the y-axis, MPK. How do I get marginal product? I differentiate production function with respect to labor, dF over dL. How do I get marginal product of capital? dF over dk. What is the marginal product? Differentiate this with respect to labor. You will get K 1/3, 2/3. Here is where I can make a lot of mistakes, so please be on your toes and tell me. Shout it out. 2/3 minus 1. K 1/3. 2/3 L 2/3 minus 1, and if I differentiate my production function with respect to capital, I will get L 2/3 1/3 K 1/3 minus 1 minus 2. This is minus 2/3 minus 1 is minus. Okay, got it. Okay, this is my MPL, MRTS. MPL over MPK. Let me simplify. Always simplify. It's much easier. 2/3 over 1/3 is 2. K 1/3 K. L minus 1/3, 2/3, L. Got it. This is my MR here. And that should be equal to, this is the slope of the isochron, that should be equal to the slope of the isochron. Equation 1. Okay? Equation 1. From here you know that L is equal to 2kr over W. Okay? Just substitute 2kr over W. And whenever you are solving a constraint optimization problem, your second equation is always the constraint. Always the constraint. What is the constraint? Q is equal to L 2/3, K 1/3. This is equation. Equation 1. Equation 2. What do? Two equations and two unknowns, L and K, you are solving for them, you solve simultaneously. L is equal to 2kr over W, so just put it in. 2kr over W, 2/3, K 1/3. Okay? Once you do that, solve for K star. I'm not going to solve the algebra. K star, I'll cheat. W over 2r, 2/3 times C. This is K star. This is your conditional demand for capital. Okay? Understand the logic, huh? Solve these two equations simultaneously, you will get K star. That's what I'm trying to emphasize, not the algebra. Okay. L star, once you get K star, you have L as a function of K, substitute the K star back into the expression for L, you will get L star is equal to this fellow, is equal to, again, 2r over W, 1/3 Q. Okay, this chap is here, this chap is here. Got it, the conditional equation. Okay, now the second part of the question. This is pretty simple, standard, okay? This is the, you can't make a mistake with this, this is the basic. The second part of the question asks me for the cost function. Let me just do it here, just so as to show some utility. I'm going cost function. Cost function means the cheapest way of producing output level Q. Am I already on the isochron? Okay, no problem here. I don't have to give myself a general isochron for Q because I'm already doing the conditional input demand for the generalized output level Q. Okay. So the lowest cost of producing the output level Q is the cost function, and I know it must be a function of the output I want to produce Q, the unit price of labor W, and the unit price of capital R. It must. Okay, I'm looking for a cost function like this. How do I do that? Well, this is the bundle that represents the cost minimizing bundle for producing Q. Therefore, the cost of this bundle must be the cheapest way of producing Q. This is the bundle that minimizes the cost of producing Q. Therefore, the cost of this bundle must be the cheapest way of producing Q. What is the cheapest way of producing? What is the cost of this bundle? This is L star. So it is W. I would rather you played Beethoven. Okay, W times L star plus R times K star. K star is this. W over 2R, 2/3. Okay, this is the cost. You will simplify, of course. This is not the end of it. You will simplify it. But notice the important thing, you must always check when you give me a cost function. Does it contain a Q? Yes, it does. Does it contain a W? Yes, it does. Does it contain an R? Yes, it does. So it is. That's the last thing you must always do. It must be a function of what you expected it to be a function of. Output, wage rate, and interest. You will simplify, you will solve it, and you will simplify. I am cheating. The cost function will be this. power 1/3, 3R to the power 1/3, W over 2 to the power 2/3, Q. This is the cost function after you. After you do the simplification, multiply W in, take Q out, common, do all of those things. Again, function of W, R. Okay. Got it. Part 2 of the question. Okay, this is standard thing. You must know the relationship between conditional input demand and the cost. Part 2 of the question is this. Now I am given a demand function. Let me write down my cost function here. So you recall this, you will keep this in mind always. Your L star is this, 2R over W 1/3 over Q, this is I'm just copying. A star is equal to W over 2R 2/3 Q. And your cost function, CQ. I'm not writing W over R, W and R, but you know that it's a function of W. 3R 1/3, W over 2 2/3. Okay, I know this much. This is what I have derived. Now the next part of the question asks me this. I am given a demand function, and the demand function is this. U is equal to 21 minus 4P over 8. This is my demand function. I am given a demand function. And I am asked, what is the firm's optimum output level? Q star. What is the firm's optimum output level? The moment you see the firm's optimum output level, optimum, that word should trigger a response in you. The response should be, when I am looking for the optimum output level for a firm, I am looking for the profit maximizing output. That's it. Optimum output level, profit maximizing output level. How do I get the profit maximizing output level? Pretty simple. Maximize profit with respect to Q. That's what I am solving. That means I will do d phi over dq. Whatever I get, set it equal to 0, solve for Q star. That's what I am looking for. Okay. Maximize profit. What is profit? Profit is a function of revenue minus cost. So profit is revenue is price times quantity. Quantity is Q. Price. Now notice, guys, this is something that you should always pay attention to. My demand function is given to you here, but this is the demand function. I want a price here, so the price times quantity will give me revenue. So I have to, if I am given a demand function like this, my first job is to get an inverse demand function. Price as a function of quantity, always. HQ. So I am making price the subject of the formula, 21 minus 4P. So 4P is equal to 21 minus 8Q. P. This is the demand function. This is called the inverse demand function. And whenever you are calculating revenue, you need an inverse demand function. So let me put that down. 21 minus 8Q over 4. This is my revenue minus my cost. Here is the cool part. I have already calculated my cost function. This is the cost function. Okay, this is the cost function. This is the cost function. So 3R 1/3, W over 2 2/3. Nice. Okay, this is my cost function. If I differentiate from here I'll get marginal revenue. This is your total revenue. This will differentiate to get marginal revenue. I'm differentiating with respect to Q. 21Q, let me just do it. 21. 1/4 remains here. 21 minus 8Q squared minus 16. This is my marginal revenue, right? 21. I differentiate this with respect to Q, I get this. My marginal cost, I differentiate this expression with respect to Q, I just get this. MC MR equals MC MR. Familiar condition, MR is equal to MC for profit maximum. here you notice that Q is the only unknown. I am told W is equal to 1 and R is equal to half. So I can plot it here. So 1 over 421 minus 16Q. W is equal to 1 and R is equal to half. Half to the power 1/3, W is 1. So half to the power 2/3, half 1/3, half 2/3 is just half. Minus 1.5. 3 over 2 is equal to 0. Notice, this is the equation I need to solve.